Hello, this is Vasvi from At Home Tuition. So here I've taken the topic rational numbers and their decimal expansion. So let's first know what a rational number is. Rational numbers are of form P over Q, okay? Any number which you can represent in the form P over Q, where your Q should not be equal to 0, okay? And when you expand this P over Q, that is when you find the factors of the denominator Q. Here when you divide P over Q, there are only two cases which you can have. One is it should be a terminating decimal number, okay? That is your after the decimal point it stops at some point, okay? So if it terminates, that is at some point your remainder would be 0. Either it should be that or it can be non-terminating too, but the decimal numbers would be repeating, okay, recurring. In that case also you call it a rational number. So I say any rational number could be written in the form P over Q, right? When you divide the P by Q, you have only two options. It terminates, okay? Either it terminates or non-terminating but repeated decimal expansion, okay? Non-terminating and recurring. I'll show you with example. So, for example, here for terminating number, you can say 1.5 or you can say 6.42. There it ends. Your decimal place, here you have only one digit after the decimal place and here you have only two digits. You know how it ends. So in that case it terminates. The decimal numbers doesn't go further. It can either be that or if it is not terminating, it may be something like this. 1 over 6666666. Likewise it keeps going, right? Or you can say 0.333333. It is repeating. The 3 is repeating. Or you can even say 5 over 123 123 123. Either a single number will be repeated or a set of numbers would be repeating, okay? In that case also you can say it is a rational number. So now next is terminating rational number theorem. In this theorem they say if x is the rational number, okay, let x be the rational number whose decimal expansion terminates, then x can be expressed in the form P over Q, where P and Q are co-prime, right? And the prime factorization of Q is in the form 2 raised to n times 5 raised to m, okay? In this case, the n and m are non-negative number. It should be a positive number or a 0, okay? So here, I explained this. If it is a terminating, I told you have two options here, right? One is terminating and the other one is non-terminating but repeating. Okay, if it is a terminating rational number, then what they say is, when you find the prime factorization of Q, okay, the denominator, you can write it as a factor of powers of 2 and 5, product of the powers of 2 or 5, okay. In that case, you say it is terminating. If you cannot represent it in this form, then you say it is non-terminating. So here too I'll give you example. So say for example, you have the same example which I have given you here. I take like 1.5, okay. This could be written as, see, this is terminating number. Here, if you just make it as a fraction, it is 15 over 10, right? This 10 can be written as, the denominator is Q. Just find the factors of, prime factors of 10. It is 2 times 5, right? So this is terminating, right? Because you have it as 5 and 2. Now you take another example I've given for terminating number. It is rational number. It is 6.42, right? And you know it ends at 42. So you can make it a fraction like 642 divided by 100, right? When I make it a fraction, it becomes 100. Don't bother about the numerator. Just leave the numerator. You don't do the long division or anything. Just find the factors of 100. So that would be 2 squared times 5 squared, right? See? So this will be the multiples of 2's and 5's power, okay? So this is also terminating. Just take one non-terminating number, 1.666666, it keeps going. You don't know how many numbers it comes, it is infinity, right? So you can't write this as a fraction because we don't know where the decimal numbers ends, okay? So this cannot be written as a fraction, and thereby you cannot check whether the denominator q is in this form. Understood? I don't want to explain more about this. Let us do the problem so that you'll understand. Without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or non-terminating decimal expansion. So I said, when you get such problems, you're not bothered about the numerator. Just take the denominator and find its factors. Okay? How do we find the factors of 3, 1, 2, 5, right? Since 5 is the last number, I divided by 5. So this would be 6, 2, 5. Divided again by 5. You get 1, 2, 5. Dividing it by 5 again, I get 25. So this is 25 is 5 again. I divide and this is 5, so I can stop here. So this is like, this could be written as 13 over 1, 2, 3, 4, 5. 5 raised to 5, right? See, in the denominator it is 5 raised to 5, sorry, not 2, 5 times. So 5 raised to 5. So the denominator you have only two, you should have only 2 or 5, or you can have both. In that case only you say it is terminating. So this one is terminating. Okay. So I would write T for terminating, and non-terminating I write NT. Okay. So this is terminating. Okay. Now the second one, again take the denominator. It is 8. Let us just find the factors of 8. It is 2 times. Even number, right? So I divide by 2. Again I can divide by 2. 2. So that's 2 cubed. It is 17 over 2 cubed, right? So this is also a terminating number. Got it? Now do the third one. So simple it is. Just look at the term, the denominator, and do prime factorization. You get the answer. You needn't even do the long division and check the answer. Here this is 91, right? So let me divide by 3. So this is not 3, sorry, 7. I can divide by 7. So that's 113. Yeah. So only this much. So here your denominators are 64 over 5 times 7 times 13. So here see, you have 13, 7 all as denominator. So this implies it is non-terminating repeating decimal. Okay, I write repeating, non-terminating and repeating decimal. Okay, NTR. Okay, here again let's do this 1600 or 1600. This I can split it as 16 times 100. So 16 is going to be 16, I can write it as 2 raised to 4, right? Times 100 could be written as 2 raised to 6 times, 2 raised to 2, right? 2 raised to 2 times 5 raised to 2. So you can see that it is all 2's and 5's here. So I can say it is terminating. Okay? And the final one over here is 29. Don't bother about the 29. Just leave the denominator as it is. This is like 3, 4, 3, right? 3, 4, 3. I think 3 cannot go in this. Maybe 7 goes. So that's 28 4 times. Okay, this is 49. Again you can divide by 7. So that's 7. So here you can write it as 7 cubed. So this is 7. So it is non-terminating and repeating decimals. Okay. So we are done with this. Now let's go on to the next set of questions. Here they say the following real numbers have decimal expansion as given. In each case, decide whether they are rational or not. Okay, if they are rational and of the form P over Q, what can you say about the prime factors of Q? Okay, now let us do this one. Since you know how many numbers you have here, since it is a terminating decimal number given, I can write this as 43, 1, 2, 3, 4, 5, 6, 7, 8, 9 over 10 raised to 9, right? So this could be written as 4. The numerator we are not bothered because we are not going to use it at all. I just wrote it as fraction now. 7, 8, 9 divided by this 10 raised to 9. I can write it as 2 raised to 9 times 5 raised to 9, right? So here this is a rational number, okay? It is a terminating rational number. You just need to say whether it is rational number or not. Okay, so this is a rational number. 2 raised to 9 and 5 raised to 9, right now? So when it is in this form, you can say it is rational number. Now look at this number. Since it is repeating, here they have given you dot dot dot, right? So we don't know where it ends. So this is non-terminating. Okay, if it is non-terminating, then at least if it is, so I can tell one point as non-terminating. So if it is non-terminating also, you can just see whether it is recurring or not. And it is also non-recurring. It is not the same thing repeated, right? So I call it a irrational number. Irrational. So that's done. Now the last one here. The line on top of these numbers shows that 1, 2, 3, 4, 5, 6, 7, 8, 9 is repeated. Okay. So here this is non-terminating because we don't know where it ends. But still it is repeating, recurring. So I can write non-terminating as well as recurring. So here this is rational number. Okay. Did you understand the difference between rational and irrational number? Once again I repeat, rational numbers are in the form P over Q, and it can either be it can either be a terminating decimal expansion or a non-terminating but recurring. Okay, see, that is mandatory. I keep stressing on this recurring. It has to be repeated. Okay, decimal expansion. And then irrational numbers are all numbers which you cannot put it in the form P over Q. Okay, so those are known as irrational number. They just keep the decimal digit doesn't ends anyway. The irrational numbers are non-recurring, okay? And it is non-terminating also. Hope you are clear with these. Thank you. Have a good day.